So firstly, in week 8, we have a few topics. Today I only plan on covering a couple of them, which is going to be a brief to softmax regression and a little bit about KNN. So beyond that, in the subsequent session, we'll take the remaining parts, which is SVM, and there is some text-related stuff that we're going to cover. So firstly, can someone give me a brief as to what logistic regression is? What is it used for? How does it work? Things like that. Any idea? No takers for logistic regression? Even one, two lines, the very basic things is fine if you know about it. Wasn't logistic regression a part of week 7? Okay. In that case, let's see. So firstly, what is logistic regression used for? Is it for classification? Is it for regression?
It's for classification
classification.
model.
Okay. So that part
Like
is gone. So firstly, before we even start coding, the general idea is that you should know about the algorithm as well.
like
So
it models the probability of a binary outcome based on sigmoid function.
perfect. Okay. Do you recollect the function?
Uh, I want. Can you repeat your question?
Do you know what is the function for the standard logistic?
I guess sigmoid function, if I'm remembering.
Yeah, and can you give me the expression for it?
So 1
One
divided by
by
1 plus e to the power minus w transpose x.
Okay,
Yeah, correct.
fine. So that is the logistic function. And in the case of softmax regression, it is only to be updated slightly. So when we'll get to that. So as was told, we have logistic regression that we have seen so far. So we'll go through the documentation as well as we generally do. So used for classification. And then we have gives probability between 0 and 1. Right, so we have this. And when we take the standard logistic function, we get f of x is equal to the general expression is 1 over 1 plus e to the power minus x. And when you add your weights, it it accounts for the function as we see it at the end. So now with this, the next thing is what is softmax regression? So softmax regression is simply, normally we use this logistic regression for binary classification. So if it is just two classes, then we use logistic regression the way we see it. But when we have multi-class, that is, you might have seen your MNIST data set, anything basically with more than two classes, then we need a way to get values or be able to get some value with which we can say this belongs to these particular classes. So now here, if I were to use, I might get some value like say 0.3, 0.5, 0.7, basically some value between 0 and 1 I'll get. And the idea is that if I can tell it belongs to one class with 0.3, it also means that it belongs to the other class with something like 0.7. Now, if I have to extend this particular idea to multi-class setup, how do I do it is the question. So for this, we come across the softmax setup, or rather the multinomial case. So this one makes, this is going to be a slight difference, wherein instead of having just for one particular value, we are now going to have something like e to the power zi by summation over e to the power zi, where I will go from 1 to k, where k are your number of classes. So say we have k classes. So you can try this expression on your own later on as well. So if you just put in values, now this is going to give us a set of probabilities. So if there were k classes, each one will take some value now between 0 and 1. And if some class has a very high value, it might take something like 0.8, and it keeps going for whatever k values are there. So now what does this do us? We wanted a way to generalize the logistic regression setup such that we do it for more than 2 classes, or rather multiple classes. Now we have a setup for it which is based on this expression, and we can choose now whether we want to go for the maximum value or we need to go for some other setup. So this is relatively simple, but the reason why I did want to bring it up in this session is the idea of sigmoid and softmax is going to be extremely important when you do your deep learning courses and such. So if there are any of you who are not comfortable with these ideas, you can see that it is fairly straightforward. I can put some value for x, and you just substitute it here, and you'll see that it gives a probability value in these ranges. So do some calculations by hand, and you should get comfortable with it. Okay. So with that, now let's go over the documentation. I hope my screen is visible. So with this we come to the logistic regression documentation. Now, yeah, as you can see, this is the logistic regression classifier. So this is a misnomer. So even though the name it says regression, this is a classifier, and it implements whatever we just discussed. It takes in some values and gives us a value between 0 and 1. So what are the other things it takes up? It gives penalty. It gives there is a dual or primal. We'll come to what that is, and then we have some tolerance. We have this term C, and then we have whether we need to fit, intercept, and so on. So before that, we'll go to this user guide. And now when we come to logistic regression, you're going to see the expression for it. So this is what we just saw, 1 over 1 plus e to the power minus W transpose x, as I think Piyush mentioned. So this is nothing but what we have for sigmoid. And this expression that might be looking complicated is what we use for optimizing. So this is not actually all that complicated. So here yi is one of the classes, 1 minus yi is that it being not that class. Then you have some probability for it, and then this term is your regularization or penalty. You don't need to memorize this term, but you do need to know what are the things that are involved. So with this we see that okay, there is a regularization component for it, and that this is a function that needs to be optimized. So now if I come back to the documentation, I know that there are a few things. Firstly, there is penalty that can be set, and penalty I've kept doing this multiple sessions, so I'm not going to ask you again. So you have either lasso ridge or elastic net, where in the case of elastic net, both of them will be considered. And then we just saw that there is an optimization function. This says how you would want to go about it. Do you want to go for the dual formulation or the primal? And then there is a stopping criteria, as in after how many, because not all equations will you end up with the optimal solution. So in that case, you might want to stop early ahead of time. And this is a tolerance, this one for it. Another important factor is the value of C. C is regularization strength, and specifically in this it is the inverse of regularization strength. So with this, if you have very small values, that means you are giving very high regularization. So can someone tell me what happens if the regularization is too little or if there is too much regularization. Any answers for that?
Yes, sir. If there is too many regularization, like the model will fail, like it will overfit. And if
If
it
there
is
is
too
too
little,
much,
it
it
will
will
under.
overfit, or if it is too little, it will overfit.
That's little. It will overfit if the model is too much. Like, there are too many data.
Okay, if there's too much data, it can overfit.
Yeah.
What about in terms of regularization?
I mean, if we have very much regularization, it also overfit. Like it will just have learn the model. It won't. Well, it will just remember the model, not learn anything.
Okay, so on the contrary, so regularization is something we do if we find that the model is overfitting. Okay, so uh, what regularization does is like it gives penalty if the model is relying on some feature too much. Okay, so but like I will take into cognizance of what you said in the sense that we might not always say in a case by case basis that it will always cause overfitting or underfitting. But if you think about, say, something like the lasso setup, where many of them end up going to zero, it is telling the model that you should only focus on these relevant features. So the more I regularize, I'm adding more and more constraints. So the model tries to not, give heavy weights to a particular feature, or it will try to reduce the number of features, and there's a chance that it can underfit. So usually, at least in practice, whenever there is a chance of overfitting, that time we can try adding some more regularization. Okay. So with that, let's come to a practical scenario where you might see it. So when do you know that your model is overfitting? What is the indicator? How will you test that your model is overfitting? Any ideas? So either today, maybe tomorrow when you attend some company, they give you a data set to work on, or maybe in your MLP project when you do it, you are given a data set. What is the sort of code snippet when you run, or what values when you see, will you get the idea that okay, maybe my model is overfitting? Any idea about that?
Sir, we can track the test error or maybe
Okay,
the validation error. Once it's start getting it's start increasing after certain iteration, maybe that's the point after which the model start overfitting.
okay. So specifically, we can say that if the test error keeps increasing, but our training error is continuing to drop, our model is starting to overfit. Right. What is a common model where you might have seen overfitting? So by now, I feel you might have tried a few of the models. Were there any models where you quite often find that the model ends up overfitting? Any idea about this? No? Okay. So, okay, decision trees and all, it comes in subsequent weeks, but there are these models, decision tree and associated models, like the ADA boost model. So quite often we end up seeing that if we don't set in the parameters, which of course the hyperparameters we'll discuss in the next week, the model tends to overfit. One other way is by now you all might have done this confusion matrix display. So if you have not done that, you look it up what it is today, and in one of your models you run it. Yeah, is there a question? Yeah, please go
Uh,
ahead.
yes, sir. Yes, sir. There was a question. So, like, I wanted to ask now. Like in the question, it was asked to do 100 epochs. Okay.
Hmm.
But what I did, instead of taking max cycle equals 100, what I did is I took max cycle as 1 and warm start equals 2, and later on I ran the loop for like 100 times and then
Okay.
predicted the loop. So which one is more like precise, like the using max cycle equals 100 or using max cycle equals 1 and then running loop?
To be honest, it should not cause that much of a difference
No,
because you are
sir.
using.
Actually, it was a method, a different error. Like what I did now for week 6 video assignment.
Mhm.
I did the same thing and and I ran the loop, but
Okay. Did
I
you
got
get
different answers.
very
Yeah, I
varying
defined.
results?
No, not very varying, but like obviously, even if I have like my answer was 5, and the answer that was supposed to be right was 6, so it was just one error, but like it
Okay,
was
okay.
very
I don't
yeah,
recollect
it was
what the
a
exact question is. I can look it up, but yeah, the point is if In general, I would say if you are asked to do it for these many iterations, then I would personally go for keeping the remaining settings as it is and just and
That's
max iter is something that says when you need to stop. So it is not saying how many times you need to run.
Yeah.
So this is how many iterations. If it does not stop, that you need to, you need to stop there. If the training has asked you to run it for so many number of iterations, then you have to do like whatever you just said.
No, it was
So
actually asked in the question pretty clearly to run the iteration for like 100 times. For
okay,
100
okay,
epochs. Yeah.
yeah. If you have to run it for 100 epochs, then actually you'll have to run it for 100 epochs just like that. Max iter only says when you need to stop it.
Yeah,
If it does
exactly,
not
sir. So that's yeah, exactly. But I made like I did the same thing, but I got two of the questions wrong.
sure, sure.
Yes.
I'll look it up. Do you have a post on discourse on this?
Yeah, I have posted this course.
Okay, okay. I'll check with the team on that. Okay, so
And
going
there was
ahead,
another
yeah,
error. Yeah,
yeah,
so
go
I was
ahead.
saying now there was another error in week 6. Like there was no mention of using validation set, validation fraction, but in the previous assignment solution that was provided on the collab, sir used this validation fraction equals 1. So like there were two things that weren't mentioned that I did them, and two of my questions got wrong. Because
Okay,
please
okay.
look into it, man.
Sure, sure.
Yes, sir.
Yeah. So yeah, moving on, we have some more parameters here, and as I was mentioning, there is one for regularization strength. So these things also, I would recommend that you all practice with this, and this, while it might seem like it's a memorizing thing, I would still recommend if you practice enough, you'll kind of get the hang of it. So both, at least map it like this: support vector machines and logistic regression. Having a smaller value gives more regularization. And then there are a few more parameters. Another important one I would like to highlight is that of class weight. So you might have learned techniques like SMOTE. And again, in practice, you might find that if you oversample or undersample also, sometimes there might not be much difference to the scores. So in that case, you can go on with using class weights. So that is a pretty good approach. Then there is random state. So again, it is only applicable when you use certain solvers. And previously, we had discussed in one of the sessions that using these SAG, which is gradient descent based things. So there is an aspect of randomness to it, and that dictates what random state you use as to what solution you will get. Then there are solvers again, which is the same. So here, the reason today the topic we have is softmax regression. So here is where the first sort of diversion comes. That is, for multi-class problems, there are not all solvers are applicable for it. So you can see this multinomial multi-class. So the softmax regression that we have, there is no separate implementation thing for it. It is just logistic regression, but the data set will have more than two classes. That is, it is not binary. So which of the solvers are applicable? You need to check this, and based on that, you can use it. So then there is max iter, which is after how many iterations do you want it to stop. Then now this is where one difference is. So you might have seen a question in activity questions or even in the profs videos. There is the use of multi-class and the idea that you have to select multinomial, but sklearn is moving away from this kind of setup where it is, you can see this here, deprecated since version 1.5. So that is why do make sure that you use the documentation regularly. So from now on, it will automatically take care of the multinomial setup without having to explicitly be mentioned here. Okay, so that is one change. Then warm start, we've also discussed previously. This is when whatever you've done as a previous fit, you want to build on top of it. So that is warm start. And then n jobs is more of a CPU thing. I wouldn't pay too much attention to it right now. And then there is L1 ratio, which is only if you've used ElasticNet, the first regularization thing. The other things, I think I mentioned this in the revision session for the OPP as well. So the use of attributes is very important. So if the idea is to just build a model, then anybody can do it. But the point is, after that, you look at these attributes, you look at what these values say, and try and interpret it. So that is the other part. Okay. So that is primarily with the logistic regression or the generalized version of it, which is softmax regression. So here, if I click on user guide, I come to this page. Do go through this also when you get time. There is some very nice, almost a limited amount of theory that is there, which is helpful to learn. So you have the function, you have the optimization function, and then what happens to the penalty, how it changes for a multinomial case. The expression for that also is given. And then some more information about solvers, which is valid where, all these things. So do go through this. It's not very easy to keep all these things in your memory, but as and when required, you should be comfortable with going through the documentation. Okay. So now let us move on to the next algorithm that we have for today, which is k nearest neighbors. Probably directly just. Okay. So any information about k nearest neighbors? Can anybody give a brief on that? What is the KNN?
Yes, sir.
Yeah.
Yeah. So the k nearest neighbor, what it does is now like it puts the value in a place where like for or like if we set like for k n if we put value of n as 3, then what it will do is it will compute all the pairs of three data samples, and then what it will do is it will select the mean that will get the value that will get after selecting three data samples. Then their distance from that point.
Okay.
There only we will put the volume value that we have to put, like the value will be classified in that section.
Okay, so we given a data point, you look at distance with whatever value of points we have, and then we'll take a mean, something like
from
that.
all the pairs having three data points in samples. And
sorry, from what?
From all the data samples that we have,
okay.
we will
from all the data centers.
From all the data centers, we will take 3 pair and we will just put the point in that data center from where the distance is closest.
And so data centers, no, that is in the case of k-means clustering. So this is k nearest neighbors algorithm.
So this will take data samples then.
Yeah, this is with all the points. So before, so we'll see it. But with that, let's also start directly coding a little bit. So now I need you all to tell me how to load. Is there a question?
Yes, it is a question, but I don't think it's relevant to the sklearn KNN basically. So can I ask? It's related to machine learning only.
Okay, then we'll finish this topic and then we'll come to it. Okay?
Yes. Yes.
Okay. Yeah. So with that, one of the things, sort of a common thing I've seen with many students is, even after finishing the course, there is some difficulty when it comes to coding with just the use of the documentation. So now we are going to try and overcome that a little, which is by actually practicing. So now I need you all to give me the code snippet for loading a data set. Specifically, I want to load the California housing price data set, which I think is a regression data set.
Yes, sir.
Yeah, so can I get code snippet for it? So you can, if you want me to open the documentation, you can ask me to open the documentation and we can go through it. But let's see. How would you do it? What should I write?
You should write from sklearn.datasets import fetch California housing.
Okay, from sklearn.datasets.
Dataset import fetch California housing.
Import
FE fetch California housing. I guess there was a underscoring between fetch and California and housing.
Okay.
And after housing.
Is this correct?
Yes, sir. I think that's correct.
Okay.
Or maybe it is California housing dataset.
Sorry?
I guess it is correct, sir.
Okay. Yeah, if necessary, we can always go to the documentation.
Yeah.
Now, we are doing this as an activity where you guys will direct me what I should code. I'll do it and we'll go about the process today. But with this, you should understand that this process can be done by you guys as well, wherein you don't need to rely on other tools to do your coding for you. And that is going to be very detrimental if you can't do it on your own first. So once you're very comfortable, it is a different thing. Okay, so what next? What do I do now?
we will like split the data from fetching fetch. We'll have the data list of data or the data frame of data. First, we should import the import PD as pandas and then numpy as NP. We should import this.
Okay, so import pandas as PD. I think you
PD,
mentioned
yeah.
it the other way around,
Yeah.
but yeah, okay.
Yeah, exactly. And
Yeah.
and numpy too.
Okay. So import numpy
As
as
NP. NP. Yeah, so now what we're gonna do is from fetch California housing.data, we're gonna create a variable called data that will have all the data frames.
okay, but tell me what is the line of code first? I'll write it, then you tell me what is to be done.
Yeah, maybe we should write X, capital X equals
Okay.
fetch California housing
Okay.
and dot data.
Okay. Dot data
Yes, sir.
with the brackets, without the
Use,
brackets.
no, without the brackets.
Okay.
Yes, sir. Oh, it
Um,
was here. Okay,
we first need to call this California housing data. So above this code line, maybe you can write data is equal to
yeah,
California with bracket,
Okay.
yeah. And then
Now.
X, in the next line, X we can import X and Y together. X comma Y equal to
Okay. So we'll go with a
after this,
different approach now.
data dot data
X comma y equals to data dot data. Okay.
comma data dot target.
Okay.
But in California housing within bracket, import it as
we will
a
be subset equals string. Subset
Okay.
equals and yeah,
Subset equals
apostrophe.
train.
Train and train will have that apostrophe like colon and symbol.
Okay. This is what you
And
wanted
I
me
guess
to do. Okay.
yes,
And
yes.
I think someone else was saying was it Avinash who was suggesting doing data dot data and data dot target. Did you also want the same thing?
no, sir, I'm not sure about the subset. I would
Okay.
import it as a as frame equal to true, and
Okay.
yeah,
As
within the
frame.
bracket.
Okay.
uh,
As frame equal to true. That's it.
just try this code.
Okay. So we will run both of them. Okay. So first, let me run this. Okay, so here what do we have probably got an unexpected argument subset. Okay, so I don't remember the name. You have 24F100
Yes, sir. Yes, sir, it's me. Yeah, it's
Yeah,
me.
what's your name?
Harshvardhan, sir.
Okay, yes, that's right. Then what do I need to change here?
Maybe
Any
remove the
idea?
subset and just call it out without putting anything inside the bracket.
Just subset, huh?
Removing this
Okay,
and that too, like remove the subset too. Like we just need
okay,
to call the function. Like yeah,
okay.
now I guess it's
So
okay.
yeah, this of course gets it. It's let's do this. We'll come to what Avinash suggested as well.
Avinash,
So
yes.
now I want one of you all to answer me. What output will I see when I use x dot head? So what will I get?
H dot what, sir?
X dot head h. Yeah. What output will I see?
So it will return the like first five outputs.
First
It
five
will
outputs.
Yeah.
Anybody else?
five.
Any answer? Yes,
Feature
Avinash?
matrix.
Yes.
Sorry.
First five rows of the feature matrix.
Okay.
Yeah.
So anybody else? Any other answer?
Or say maybe if the data is imported as numpy array, np.array, then what will happen is you won't get this feature. Yeah, exactly.
Yeah. So
Exactly.
this is the catch.
Yeah,
So
exactly.
otherwise, I mean, I've been asking
But
data
if
dot
we
head
run,
for a
but if
long
we,
time.
yeah, but if we run Avinash's code, na, then it will give what we want.
Yeah, so this is one
Because
thing I want you all to be aware of. So when I said that students struggle to import, like write these few lines of code, right? This is where they struggle. So there are these tiny nuances. It is not just writing these lines of code the first time, but also figuring out the error. So now when you read this error, you realize one thing, that your data type,
is np.array.
yeah, so it is numpy.end array. It's an n-dimensional array. So this
Yes.
should give you a clue that okay, I am not importing it as a data frame. So I have two options. So either I can convert this to a data frame, or I
Yeah,
can choose to
using
import
P.
it as a data frame.
Yeah,
Can't we do it directly in?
yeah, we can do it.
As
Like,
in, yeah, we
using-
can do it directly. So that's what we'll go for.
Yeah.
Now we'll go for the second method.
Yeah, and this will return head. This will be some noise.
Yeah, so let's say 2 for importing. So now we have as frame equal to true. Now what will I see when I do type of X?
Data.
Okay. And what about type of Y?
It will be the same, sir.
Will it be
Just
the
different
same?
number of but different number of columns.
Okay, there is a slight difference.
With series, yeah.
Yeah, so it is
Series.
a series. So if you all remember, I had spoken about this also, dir of PD. If we go, there are different things. So you have data frame as one thing, and series is slightly different. You are right in that it will only be one column, but the things that you can use for the two of them will be different. So again, this is more from a debugging point of view that you might have to do later on. So that time it will help knowing these data types. Okay.
Yes.
So fine, we have finally managed to load our data set. So with this, let's also go for another one, which with time I like using, which is to make use of both the things in one go. So which is return xy equal to true and as
Yes.
frame equal to true. Okay. Maybe before I run this, let us do x dot head. So x dot head, as you can see, it works properly. So for a difference, let's just do this. As you can see, this also runs properly. So this just makes it into a single line instead of having data.data and data.target. So for those of you who might not have been familiar with this, so we'll also see how we could have done it from the documentation. As you can see, fetch California housing is present in sklearn datasets, and it takes in two parameters, return xy, which is to give x comma y, and as frame, which is to get it as a data frame object. So we just saw if that is not there, it is going to give it as a numpy ND array. The other parameters not necessarily that important. And the thing that I think Avinash and all suggested is where we did data.data and data.target. That is where you have to see what it returns. So if you see, it returns something called as a bunch object, so which has something called as data and something called as target. So it also has feature names. Maybe let's list that also down. Let's do. Not sure if this is directly. Yeah. Okay, it does. If I do data.feature names, it gives me the column names. Okay. So that is done. So with that, we have successfully managed to load the data set. Let's go with x comma y itself. So yeah, the other thing is for there's also this example view. So you can directly get it from here. So this shows how you import, how you write one line of code. And then within the parameters, if you had given as frame and return xy, you would have gotten it as these two things. So now that we have x and y in our hand, the next task I want to do is I want to build a KNN classifier or a regressor. What should I be building? What should I build for this data set? California housing. Any idea what data set this is? No idea what California housing data set is? Yeah, when you see this, what do you feel it is?
Yeah, sir. It's I guess it is a classification data set.
Okay.
Yes.
Yeah, so if we go to the documentation, unfortunately, it is a regression data
Yes,
set.
regression actually. Yeah, there were numbers now.
Yeah, so California housing is, I think it is about the price of house, and these are the features that are there. What is the median income? What is the in that area, what is the age of the house, how many rooms are there on an average, bedrooms, what is the population, average occupancy, latitude, longitude, and so on. So there is, let me see if this thing works. Okay, so I think it doesn't work.
It worked on one, sir.
It's x dot describe, sir. No, describe.
No, I'm not trying describe. So describe is to get the
All
other
the
details.
numerical, yeah, statistical data.
Yeah, so I'm doing it for this bunch object. So I think I have to do data dot. Okay. Yeah, this is what I was looking for. Okay. Yeah. So again, the thing that I knew that the method was DESCR, but I was implementing it on the wrong thing. So when I went to the documentation, I realized that DESCR is a method of this bunch object. So just give me just 1 second. Yeah, sorry about that delay. So yeah, so it is there in a bunch object. So which is why I had to use data.dascr, and to get it in proper formatting, we have to do this. And this is within the sort of Colab environment itself. We can get information about it. So the target variable is the median house value for California district, expressed in hundreds of thousands of dollars. So whatever value we saw here, so 4.526 into 100,000. So whatever that becomes, 452,000. So something like that. So this DESCR gives us a brief description of the data set. Okay, and now we have it. So with that, I know that we have to do KNN regression. And how do I implement KNN regression? I want the code for it.
Yes, sir. So from sklearn.neighbors, we will import KNN, k nearest neighbor.
From sklearn dot where, which do you remember?
From
which?
neighbors, from neighbors,
Okay.
dot neighbors. Yeah, we will import KNN regression or k nearest neighbor. K nearest neighbor.
It is K neighbors regressor. Yeah. Next, what next? Maybe I think should we follow something else to see if our model is doing overfitting, underfitting? What can we do for that? How do we check if we are going in the right direction?
From metrics, sklearn.metrics, we can use accuracy score or predicted score or R2
Okay,
score.
but right now I only have X and Y. So is that sufficient to say I've built a good model?
We should
Actually, we have just begun building the model. It can't be said. We haven't done anything. Like we have just selected the data. We haven't split it or anything. We didn't do anything.
Yeah. So what should I do for that?
Maybe we should first split the data and
Okay.
train size as train data and test set data using sklearn dot model selection import
Okay.
fit first fit transform train higher train.
Right. So yes, what is the code snippet for this now?
Now what we're going to do is x train comma x test, matlab x train underscore x test, then y underscore train comma y underscore test, and then what we're going to do is inside the bracket we're going to put x comma y and put test size to whatever you want, like 20% or 30%. We should put a bracket also, like to a tuple. Yeah.
Okay, but what is this one that I'm calling here?
train test.
Train. Yes, a train test split.
Okay. So test size point to work. What else should I do to ensure that I get consistent answers?
Yeah, you should get a random state. Random state equals true or equals 42.
Okay. Random state equals.
Sir, actually, now in week 7, this this issue has occurred. Like on week 7, now we were just told to do a train test split and split 30% of data, but no random state was provided to us. So there are high chances that the answers won't match what was put in the graded assignment, no? Because
Okay. Yeah.
there's
Yeah.
no
if
random
it
state
is
provided.
fine.
Yeah.
And
So and actually the graded assignment was a continuation of the practice assignment. So in practice assignment, we were supposed to use the train test split, but no random state was provided, and so
Okay.
that
Fine.
actually yes.
I'll check that as well.
Yes,
I'll
thank
go
you, sir.
through those.
Yes, sir.
Okay, so now we have made that split. So are we ready to build the model now? If so, what is the code snippet for it?
We will put assign a variable, say regression equals k and k neighbors regression bracket, and then we will put
Okay.
k and inside the bracket we will put number of neighbors that we want, like 3, 4, or anything.
Okay.
Yeah, and then we just have to fit the model on the trained data and predict the
Okay.
model
How
on
do
the
I
test
do
data.
this?
What we can do is we can like model equals
Model equals. Okay.
reg dot fet transform.
Is this correct?
So no, I guess there is
Only
no
fit.
transform method for like
Only
regression. We
fit.
should just put fit. Yeah,
Okay. Let's.
model equals.
Yeah, I think
Yeah,
Sudhir was saying something. Yes.
yeah,
Yes.
model equals.
This dot fit
Okay.
text and button.
Yeah,
Okay.
and we
And
will
what
put
do I
it on the
pass?
train data x train, and y train.
Okay.
And
What is that?
we should
Why
say
is there?
what we should do is now we should just remove n equals 3. We should just put 3 inside the bracket. That will also work.
Okay. But
Yeah,
see, here we'll do one more thing. So, can someone tell me what does this indicate? Why is there this error, and how do I mitigate it? One solution I got is to
in
just
that,
put
like,
the number, but any other solutions?
And never
yeah,
see.
what we can do is we can go on key neighbors regression, put a question mark, read the document, and there will be a specific parameter that we can use. Like
Okay.
maybe it is n nearest neighbor or something. The name. Actually,
Okay.
it's not n that defines the number
Okay.
of neighbors. It's something
Good.
else.
So it's not n. Okay. I think yeah. Yes, Sudhir, please go ahead.
I think so it is n numbers.
Okay. So it is n neighbors.
Yes, exactly. Or we can just skip it and put 3, and that will also be valid, right?
Yeah. So that is that is of course a Python related concept wherein it will just take those things in order. But if not, the way to go about it is to from the documentation.
Also, what we can also use that now, like we put the function name and put a question mark next to it.
Yeah, yeah.
Then
You can do the
like,
question mark or
there
the help. Uh, either
another
of them will come to
another
the same thing.
yes.
And so here it was n neighbors, so we just did that. And now how do I get the score for it? What do I do next?
Sir, I just
Like we need to use some metric now. Like maybe we can use R2
Okay,
score or
yeah. So let's hear from Avinash. Yes, Avinash.
Sir, I was just asking, is it okay to use this question mark and get a help during the OP session? Because I was trying
Okay,
to.
yeah. I have told in this one you can use the help, you can use the question mark, and I even showed the use of DIR method. So you can
Okay.
use either of them in the PPT. It's totally fine. Yes,
Thank-
Harshvardhan, right? Please continue. What do we do to evaluate this model now? Any answers how we can evaluate this model?
yeah, using a metric like from sklearn.metrics we can uh, import some anything like the score you want to
Sure.
use. Like we can import score or R2 score or
Okay.
yeah, or accuracy score too.
Will accuracy be applicable here?
No, it's actually accuracy is applicable only in classification data. Sorry.
Right. So regardless, here yes, we have implemented.
Yeah. So now what
We
we'll
have
do?
imported
We will
R2.
put
What next?
R2 equals R2 equals yeah. We should assign a variable to it, I guess, a loss or something. R2 equals R2 score,
Okay.
and no, actually we first have to fit the model. No, I mean predict using the model. No? Reg dot predict x y. It will be x
Okay.
dot
Yeah.
predict y.
Let's do that. Okay. How would you predict?
Yeah, we will do reg
Okay.
reg dot predict y train.
Y train.
And we should
Just
put it in a
as-
variable
as-
and name it y prediction.
Okay. So
Yeah, y predict.
we
equal-
have one solution, but there is
Equals,
some
yeah.
slight mistakes here. So that
Yes, sir.
is
The thing you should do predicament test.
Yeah, so you are going to predict it
Yeah,
on
yeah,
X.
actually, sorry, X test, and then we just have to like R2 score, and we put Y predicted,
Yeah, I think
Y
your
actual
voice
actually,
is, your
Y.
network is gone. Yeah, can you repeat?
Yes, sir. I was saying ki what we will do now, we will put the actual data set, like actual labels, Y test,
Okay.
and comma, we will put Y predicted.
Okay.
Yeah. And
Fine.
if we print R2, we will get the score.
Okay. Okay, so we got a score of 0.107. Is this a good score, bad score?
No, it is a
What
very
is
good bad score. The model is not like it's underfitting. The model is underfitting.
okay? And what is a good score of R2?
A good score of R2 is something
What is
that is
the
closer to
best
1.
possible score of R2?
Yeah, 1.0. But
Okay,
that will
and
suggest our model has overfitted. Like
okay, and what is the lowest the R2 score can go to?
it can't go below 0.
R2 score can't go below 0.
Yeah.
Are you sure?
Yes, sir.
Okay, that is an exercise that you have to look up. What is the minimum value the R2 score can take?
Okay,
Okay,
sir.
so in the meantime, let's also try this. So Reg was our model. So there is a this called score. Put this, and what does score take? It takes X test, comma Y test. So as you can see, we got the same answer. So that is because the default scoring method used for regression is R2 score. So in that case, in case you all are doing, say, with practice, again, this is something that would have saved you time, right? So once you fit, you don't have to do the import, predict, save, and then run again. You can just write one line, and you can do this directly. So even another thing is here as well. So if you were to use, say, this method, now score is not there everywhere. So maybe you want to use something like mean absolute error. So let's do from sklearn dot metrics import mean absolute error. So now here another thing that we can do is we put mean absolute error. Y test will remain as it is, and for predictions also, in case like to save from the variable, we can put the reg.predict here as well directly. So these are just some things that you pick up with time. So as you can see, the mean absolute error is 0.83. Okay, so let's after that slight deviation, let's get back to the main task we were doing. The R2 score was 0.107, and from what I heard, not a great score. Okay, and as an exercise, see what is the lowest value and what is the highest value. What does an R2 score of 0 indicate? Just basically all the information around that. So many people like asking questions along this R2, which also has another name. What is the name for R2 score? Will anybody tell me before I go here? Is there another name for R2? It is
Maybe
called
we call it R square. Maybe we call it R square score.
no, it is the name I was looking for is coefficient of determination.
Okay.
So you should know that coefficient of determination is nothing but R2. There will of course be some more information here. So I'll not go there. Okay. So we have that, and now I would like to know what changes can I do directly to improve upon these scores. So now you are told, okay, all the people I know have tried building a model on this, and they only got an R2 of 0.107. Can you help me improve this? So what are the approaches you will go for? I'm not talking about any in-depth this one that you have to do. Just some higher level, simple existing methods directly that you can use. What are things you would like to try out?
I would like to try out I would like to see first of all, are there any unknown values? We will start by removing the unknown values, and then
Okay.
we're gonna scale the data set.
Okay. Scale the data set.
Yes,
Fine. Anybody
and
else would
then
want
maybe
to try anything else? Okay. Yeah. Please go ahead. Okay. Yeah. What else do you want to do?
Outlines.
Sorry, outliers. Oh? Okay. Are there outliers in the data set? Okay. So we have a few things here. So nevertheless, what we ended up doing today is not how we would. This is because we were focusing on KNN. We directly went about building a KNN model. But if not, your approach would be that you would first check for missing values.
Yeah,
You
we
would
will
check
first.
for outliers. You would have gotten the range through something like it's not describe.
So like sir, feature elimination type.
Okay, feature elimination methods. All those things are present. So all these things broadly come under feature engineering. Now, when you all see this, is there anything? Okay, just this particular table that is there here. I want you to stare at it and tell me: is there something that evidently feels off? Are there things that definitely don't seem right to you when you look at it? So, have you built enough of a gut feeling to identify what is wrong with this picture? Anybody, any answers? What might be
Yes, sir. Outliers max is higher.
perfect? So, can you name a couple of them? So,
Average room,
right. So, average room, as you can see, again. So, we have to,
average
yeah,
occupy.
right. So, to be very specific, we can see that the minimum value is under 1 and 75th percentile is 6 for average rooms, but the maximum is 141. So, this indicates they're saying that there are,
Even average bedrooms also.
yeah, so there are a few of them with very high such values. So this is not the end of it. So what you will ideally be doing next is you can try maybe plotting the distribution of these things and what could be the solutions to this. What would you all do as solutions? Any thoughts about this? So I'm just asking a broader question of how, okay, you have found that there could be outliers, but how do you specifically classify something as an outlier? And once you classify it, what are the approaches you can take? So this is more of a feature engineering problem. Anybody, any ideas? Yeah.
Yes, maybe we can filter out those values, like
Okay.
for which it's third quartile plus 1.5 times the interquartile range, right? So
Okay.
we
So
can
that I
filter
think
all the
was what
data
was
that has
given in
value.
your OPP, right?
Yeah, exactly. That was given.
Okay. So yeah. So I'll describe some other methods briefly. One is, so there are different theories as to what can be treated as outliers and what cannot be treated as outliers. The other part is while these might seem as outliers, and there's a good chance in this particular data set, these might indeed be outliers. So some other things, there are these points can also be called as influential points. That is, because of the presence of these points, they cause some major change in some other parameters. Like your mean might be much higher than it would have been if not for these outliers. Something like that would have happened, but these outliers have caused this change. But at the same time, can we really call them as outliers is another thing. Like if there is a good number of points, they might seem ridiculously away from the other data set. But if it is still naturally occurring, then how do you go about it? Okay. So, for example, let's take one area where most of them say have vehicles priced between say 3 lakhs and say some 20 lakhs. Okay, between 3 lakhs and 20 lakhs, and then maybe a couple of them move into that location, and they buy only these luxury cars worth crores, right? Maybe like many crores. Maybe they are guys who own like private jets or something. So now clearly these things will look like outliers because the values are very different. But at the end of the day, if I am trying to communicate a story of the people around that area, so you're tasked with uh, not just a machine learning but a data analysis task where you're asked to build a profile of people living in an area. Say. So that time you are not directly going to be discarding those values. So there you have to understand that these things are there. They might not always be naturally occurring, but they are also not incorrect data points. So they did not come because of human mistakes. Because that is one of the reasons why you might have some things that look like outliers is also possible because of data entry mistakes. So first you verify what those points are, and then one approach is to separate out these things. So you can choose to treat this as a separate portion of data set and treat the remaining as a portion of data set. That is one method. Another is to cap. So you have say you figure that based on the distribution values, say maybe in this average rooms 10 is probably a good maximum value, 10 rooms. So any value that is above 10, that time you simply end up bringing it to 10. So that is another way to handle outliers. Okay. So anyway, with practice and as you try out more things, you'll figure out more methods. So yeah, this was another nice little diversion where we saw that one method which we kind of run without giving much thought also has a lot of information that is there to offer. Okay, so now we see, okay, there are outliers present, and yeah, let's also maybe see the missing values. This will give for everything.
Sir, in this data set, no missing value, I think.
Right. So it does not have any missing values. The other catch, again, I'm not saying just with reference to this data set, is this is more so in practice that you have to see. Your unknown values can be present either as NaN values, which will show up here, or people might have written it as unknown. Some people will simply write it as 0. So it might not be the value 0 in itself, but simply a placeholder that is given. So those are also things that you'll end up having to check in your data set. Okay, anyway, moving on, we saw that there were no missing values here. Next, let's go about scaling it. So how do I scale? What is the code for it?
From sklearn preprocessing,
Okay.
we should import a standard scaler.
Okay. What's next?
Next, we just have to put fed the model. Like we can use a pipeline or just fed the model using a standard scaler bracket dot fed.
Okay, but do I first need to do anything else before that?
No, we don't need to do anything. We just need to fit it on the
Okay. How do I fit it?
Using fit transform on X train and Y train.
Okay.
I maybe I guess it just takes only one argument and not two. So we can do it separate, like X train, and we can assign it a variable X, like extra as X scaled or something. Assign it a variable, I'm saying.
Yeah.
Yeah, X scaled equals this, and then Y scaled equal to the same thing, but we will use Y train.
Okay.
Replace
So
X with-
the other thing is, do I need to scale Y also?
No, we don't need to scale Y. Yeah, we need to. No, we don't need to scale Y. We just need to scale X train and X test.
So yeah, that is the other thing. You don't have to really modify your target variable.
Yeah, exactly.
Okay. And yeah, what else do I need to do?
Y scaled equals standard scalar dot I my bad. X taste anything else, like we can use any other variable. X taste scale equal to same code as above, but instead of X train we will put X test.
Fit transform again.
But we don't transform the data on the test base set. I think no, sorry. Actually, that's an error. We shouldn't like.
Yeah, right.
we
So
should
let's.
just transform. Yeah, exactly.
So let's. I'll write. the
What
code
I
for
do
it.
is now, even for like this scaling data set, I built a pipeline and just.
Yeah, that is a good approach.
Yeah.
So normally you can go with this. So you do this, and we first instantiate the scaling object, and once we have that, I can write it as something like SS.
Yeah, and remove the bracket too.
And,
Sir, we don't need to fit the data on this set now. Yeah.
yeah. Okay, so now we have X scaled and X test. we have X scaled and X test scaled. Now, shall we build the model and see if there's any changes?
Yeah, maybe we can remove the outliers and build the model.
Yeah, we'll get to the outliers, but this was
Yeah,
the
yeah, but yeah, the score
build
should
up
change.
for this. One of the build-ups for this session. So let's call the model again. I think we called it reg, right? So in case you all don't remember, reg is this regression model that we fit above. The k neighbors regression model. So again, I'm going to call that model now on the scaled data set. So X scaled is the training data set that I have scaled. And now I'm going to score it on the test data. Okay. So is the score better?
Yes, I guess this is like very better. Like it suggests the model isn't overfitting either, and it just predicts value. It's not very accurate, but yeah, it's better.
Okay. So again, when you all do your activity and as you all see it, you all will realize that this is a significant increase in score.
Yes, sir.
So we are going from 0.107 to 0.64. So typically in this, all we have done is we have just scaled the data set. So that brings us to one important question. Why did scaling help? And do we need to scale the data set when we are doing k nearest neighbors? So any description on that? Any thoughts on that?
So what scaling did now? Like it put all the values in like in a certain range. Like earlier it was like value of one.
Hello.
Yeah. So the thing is now, like earlier, like for some of the row, the value was like 500 and the other value was 2 for the same column, but for different rows.
Right.
Like see, but the thing is now, if we scale the data, there won't be that much gap between the magnitude. Like it will be 2-3 points different at max. See, there aren't like too much gap.
Yeah.
Like yeah.
So let's go over it. So as Harshvardhan mentioned, so what we do with k nearest neighbors. So if I don't recollect from MIT, so the idea of k nearest neighbors is I have this particular test point, and I have to find who his nearest neighbors are. So in this particular code that we wrote, we took three nearest neighbors. So we first find who are his three nearest neighbors, and since this was a regression task, we predict the mean of his three nearest neighbors. So say I was looking for price, and his three nearest neighbors had the value say 250, 150, and say 200. So that sums up to 600. And now when I take the average, the value ends up being 200. So I predict 200. So that is what it does in a regression case. Likewise, in the case of classification, it takes three nearest neighbors. And if it was binary classification, if out of the three neighbors, two of them voted one of the class, then it will go with that class. Basically, the majority of the vote. So that is the rough idea of k nearest neighbors. So now we know that, okay, once we find the neighbors, we just look at the target variable, which in this case was price, which looked something like this. Yeah, it looked like this, the median house value income. And based on that, it was giving some value. Now, that is after we find the neighbors, but how do we even find the neighbors? So to find the neighbors, here we use distance. So distance is the metric that is used, specifically Euclidean distance. So now if I have to find the distance of these two things, how would I do it? So first, say this, I'm taking this column 0, row 0 and 1. So if I have to find the distance between these two of them, I'll do 8.3252 minus 8.3014 the whole square, plus 41 minus 21 the whole square, plus this value minus this the whole square, this minus this the whole square, and it keeps going. So now here it should immediately make it clear to you that these values are very close to each other. They are quite similar. So is this. So when I take the difference and square it, I might not have a very high value. Whereas this one, 322 minus 2401, the difference is 2000, and when I square it, it becomes so much more higher. So whatever that value is, this once we subtract it. And after I sum up also, these other things, no matter what they do, they are not going to contribute much. So I might as well discard everything else and just use this population column to find the nearest neighbors. But we know that that is not appropriate. Because if you look at, say, maybe here we might not have any exact values, but pretty much I'll tell that, okay, you take the exact values for all these things, just population you change slightly with one of the columns, and in another column let everything be the exact, and instead of population in another row, let's take this row, maybe instead of these values everything else is different, but population is say 322. So now actually if you end up finding the distance between these 3 points, you'll end up seeing even though all the values are different, just because population is similar, it might have a closer value. So basically what I'm saying is one particular feature should not dictate the distance between 2 data points. So if it is a house, the number of rooms, the number of bedrooms, its specific location, all of them should play a role. So, and the reason why this problem is coming is because of the nature of how Euclidean distance is calculated. Because we take it along each axis, we take the difference and square. We do not ensure that all of them have the same scale. Which is why simply by scaling, we have now allowed our model to make use of all the features properly, and it has given us this score. Is this idea okay? So this is something, yeah, it is there multiple times in the course, but again, we see this that once the course is done, we realize that students have not understood this idea well enough. So again, take a small data set, try it out on your own, and see why it is necessary to scale for k nearest neighbors. So with that, your other task also will be what algorithms require scaling and what don't. The more important question is why. So this is also one of the things that you have to do. Okay, so with that you will know that, and let's also go to the documentation once. So here there are a few things. The first one is n neighbors, which we already saw. This is how many neighbors you need to consider before you take your decision. After that comes weights. So the weights can be uniform or distance, and then there is one more for user to assign. So this one basically says what weights you want to give to your points. So if you see this second one, it says weight points by the inverse of their distance. So that is, the closer neighbors will have greater influence. Whereas the default setting is that all points in the neighborhood are weighted equally. Okay. So in general, we go with this only, but if you feel given your situation it's more appropriate to go with this, then you might want to switch to this. Then comes the algorithm. This is to find the nearest neighbors. We told that it is Euclidean distance that, or rather distance is the metric that we are using, and Euclidean distance is one of them. But how do we actually find this is given by these algorithms. So now this is not something we will go through in detail. In fact, we'll even barely touch upon it. But you can get the idea that this algorithm will decide how we find the nearest neighbors. So brute force is just brute force finding all the neighbors, and this ball tree and KD tree are to do with how we store them, like how quickly we can retrieve the I think there should be one comparing the advantages, disadvantages. Yeah, it is there in one of these user guides. So I'd recommend going through it. So this ball tree and KD tree, they are used to structure how we store these distances, because we need the distance of one point with every other point, right? So how quickly we can get these values is something we'll see here. Like, let's maybe look at a small this one. Yeah, here you can see if you put the query tree.query, tree is nothing but your ball tree. It gives you the indices of 3 closest neighbors, and if you print the distance, it gives distance of the 3 closest neighbors, which is what we wanted. So this is the algorithm. The leaf size again has to do with the tree that we are using. Then comes the parameter p. P is for Minkowski metric, which depending on the value of P, it will either go for Manhattan distance or Euclidean distance. So what is Manhattan distance? Anybody, any idea?
We use mod of all the distances. We sum them using just mod.
Right. So with Euclidean distance, we take the difference and square, whereas in Manhattan, we simply take the absolute value and sum up. So that is with the distance metric. And once we do that, again, I've spoken about attributes. So we have effective metric, then we have effective metric params, samples, and so on. So these things are also present here. So let's go back to this and run one of them. So what was our spot? It was called dredge, right? Dredge dot. What are the options that are there? Let's first have a look at effective metric. So as you can see, it is Euclidean. This is because if I come back here, the default metric is Minkowski with P equal to 2. So P equal to 2 is nothing but Euclidean. Okay. So with these, that is how you'll get it. See if you can also get the number of classes from this. Maybe the number of features. So how many features it looked at before it gave before the model made a prediction. So this was a regressor. It had these attributes. Likewise, we also have k-neighbors classifier. It is regarding the primary setup, it is almost the same. So you have number of neighbors, you have the weights that you give, then you have the algorithm, leaf size, which metric you want to use. But here you'll see one difference, which is classes. And if you do this, it will tell you what are the classes that are present. So that is a difference in a classification setup. Okay. So that was k-neighbors classifier. Does anybody have any doubt with the scaling part of it, any of the features that we just saw? Any questions so far on k-nearest neighbors?
So, sir, according to scaling, you use a standard scaler. Instead of we use a min-max scaler is better than standard scaler.
Yeah, so here there is no this one of which is better and which is not. So it is going to depend from a situation to situation. So there is even SQL and documentation on that. Let me see if I can find it. So yeah, so to answer your question briefly, you can use either standard scaler or min-max scaler. The general idea we just discussed, because Euclidean distance or any distance metric is being used, it is necessary that all features are in a similar scale, which is why even if you use min-max scaling, it is fine. Even if you use standard scaler, it is fine. So let us see, let me see if there is scaling choice scaler. So yeah, do go through these user docs. One of them I remember had a comparison of which one might be useful where. We can see there are also a lot more methods. There is robust scaler, there is min-max, there is max absolute. So we are taught a few of them. There are a lot more.
In terms of sir, KNN classifier or KNN.
Yeah, even for KNN, there isn't anything hard and fast as to you have to use this one. So you can start with something like standard scaling, which is, and then go about from there. So, and like I said, like I gave this activity. So do make sure you see which algorithms require scaling and which don't. And when you see the reason for some of them, you realize they also expect the data to be, say, centered around 0. So in that case, you can choose your scaling appropriately, your scaling method, such that the mean becomes 0. So that can be your goal.
Sir, can you once tell which all algorithm requires scaling and which don't?
Yeah, so this is why I'm giving this as a task. So we already saw KNN, and I'll point one that you won't need is decision tree. So decision tree does not need scaling. And okay, maybe another one is linear based models. I will specifically say gradient descent-like models.
So, yes, sir, choice of scaling is effect on R2 score.
Yeah, so whether you scale or not is impacting R2 score, but specifically with scaling method, it should not have too much of a difference. But sometimes you'll see it is always about fine margin. So it will be trial and error. You're going to try a few different scaling methods and combinations, and you might stick with one that works best for you. Is that okay?
So, sir, linear method don't require scaling. Is it?
No, I was saying decision tree is the one that doesn't require, and the ones that do require scaling are these gradient descent based methods. Okay. So I've already given quite a bit of it, but this is one exploration that I would say you do on your own. That way it will stay better. Okay. If not, anyway, we can discuss this in the subsequent session. One of the ones that we discuss next also will be requiring it. Okay, so that is with regards to scaling. Okay, with this, can someone tell me what could be some potential problems of KNN? What do you see as issues with KNN? Can you think of what might be some problems?
Yes, sir. Actually, with KNN, the issue is not the model does not learn anything. It just like it will have to will have to fit the model each time when we have to predict. It doesn't learn anything. It doesn't.
Okay. Are you saying that once
we can't dispose of data point? Like if we are using KNN algorithm, it's not like we can dispose of data point. We need the data point if we implement this.
So that is the point. Yeah. So if we use k nearest neighbors, since it is based on finding distances between points, we'll always require all the other points as well. So the model is directly dependent on having the other data points. So we cannot get away with it. So that is one of the issues with KNN. Can you think of any other issue that might be there with KNN? Anybody? Any other problems? Cannot do away.
It is very slow because we are using the data point like each time.
So we can say it as computationally
expensive.
Yes. Because for every point, say sometimes you might end up doing feature generation. You might use one hot encoding. You might have hundreds and thousands of features. So to calculate distance is a very computationally expensive thing. The other thing, any other straightforward issues with KNN?
We need to choose the value of n very carefully, or like the model will have it won't perform well, because if we put value of n as very low, the model we will get like 100% overfitted data set.
Yeah. So here I'm referring to the number of neighbors. So this is a hyperparameter. So that means that we do not know it beforehand, and we have to experimentally find out which is a good value. Okay. So did you all learn any technique to do hyperparameter tuning?
Yeah, grid search CV.
Yeah, so we have used grid search CV, right? So how do I do it?
First we import it.
Okay.
Yes, so from sklearn actually I don't remember the class.
For grid search CV.
Model selection.
Yeah, it is model.
Yeah, maybe model selection. Yeah, from model selection import grid search CV. Then we create a pipeline.
Okay. Do we need a pipeline?
We need a pipeline maybe, because I mean it's easier for me to do that way, so I use pipeline always.
Sure. Okay. But param grid.
Yeah, and we put like we make a column, and then we will put the value. Yeah, exactly. And then we will put the value.
So is there a U in? You probably know U in neighbors in this one.
Yeah.
Okay, we have a param grid. What next?
We will we will put assign a variable first, like say grid search, maybe grid search equals.
Okay.
Equals. Now what we're going to do is and then first we put the the feature extractor that we need to use, like if you're using sklearn or reg, maybe reg. Yeah, and then we put the parameter grid. We put a random state.
Okay.
Yeah, and unless state is and yeah, they are pretty much enough, I guess.
Anything else? CV, let's leave it default.
Yeah. Cross for me. Wait, sir. We need to put some. Oh, it does not have random state. Okay.
Yeah, this is because it depends on what model you're going to use.
Okay. So like we have to put a CV now. Number of cross validation we're gonna do. Like CV equals something.
It's okay.
Yeah, I guess this is fine now. Now we can access the best parameters using fit after fitting on this.
It was called this. Let's see. So yeah, in the meantime, one of the problems with this one is that we have to find the value of k like this, and if we had a much larger data set, this would have taken a lot of time. So now we have
actually grid search itself is very computationally expensive.
Yeah, grid search itself also has that problem.
I had a data set of 30,000 data samples, and what had happened was it took around 3 to 4 hours to fed the data.
Yeah. Okay. So in this case, we see that this is the number of neighbors equal to 9 is what it is telling us is the best score for this, and maybe we can check how it does.
So, sir, previously we calculated the best model here.
Correct.
Okay.
With grid search CV, we said that, okay, so we'll go to this code snippet. So I said that one of the hyperparameters we have is k, which is the number of neighbors. And I told you to check for values starting from 1 till 10 with an increment of 2. So this gives 1, 3, 5, 7, 9, and so on. And this allows us to test with just odd numbers. So that way we won't have a type. So this either, especially in the case of classification, right? There won't be a tie between classes if it's odd number, at least if it's binary. And then based on that, we get a value. So now it tells us, okay, in your model, you use 9 as your number of neighbors, and that should do quite well. The other catch is here, we only tested until 9. So maybe if the range was higher, maybe it would have gone even higher. So we don't have a, we won't know for sure unless we try it.
So the best model we can find using grid search CV.
Yeah, so grid search CV is a hyperparameter tuning technique. So given the data set, it tells, okay, these are the combinations that you can maybe try, and it might, it has a good chance of giving you good values. Okay. Is that fine? We'll see more of this when we do maybe decision tree, because it has a lot more hyperparameters. That time things will become clearer if they are not. Okay. So with that, we get the value of k. So this was one problem with it, that we had to find this, and then we can again try it in our model and see how it does. Some of the advantages of this are that it is very explainable in the sense that you're just looking at its nearest neighbors and you're making a prediction on that. So you know for sure why your model is giving the answers that it is. Okay. So, and it's also simple to understand, not just explain, but even if you have to tell it to someone else also, to a non-technical audience also, it's quite easy to convince them of it. And yeah, the problem is only of compute, that is, it doesn't require any heavy equations as such. So it is a simple algorithm in that sense as well. So we'll briefly look at one more before we end. Let's see what it is. So the other one is a radius neighbors classifier. So there are quite a few things are similar. Your weights, your algorithm, leaf size, P, Minkowski, and all that. Here you'll imagine a sorry. Yeah. So you can imagine a circle, and your points are there. You see, there's an image in this. Yeah, you can imagine a circle and maybe your points are at the center of it. And with the radius neighbors classifier, you are simply drawing a circle around that point and then making your predictions on the basis of that. That is the primary difference. You can try out the code snippets here. Let me see if I can just. Yeah, running this will just give me the same values. But you can try it with a bigger data set and see how it looks. Other than that, it's quite similar. Instead of finding these many number of points, instead of having k as the hyperparameter, now you fix the value of radius. You say within this radius, I want to look. So then there is a problem. Okay, what if there are no points within that radius? What do you do then? So those are the problems you will have to work out. So in this particular case, it will look at this radius based on the distance metric given. In this case, p equal to 2 and metric Minkowski is just Euclidean. And within the radius of 1, it is going to look for points, and based on that, again, it is going to vote. So that was radius neighbors classifier. So this.
So what is this matrix equals to Minkowski something?
Yeah. So matrix Minkowski, if you look at it here, so the default one is Minkowski, and Minkowski it is also tied with the value of p. So if you come here, so if it is Minkowski, it takes this power parameter p, can take value 1, where it becomes Manhattan distance. We discussed what Manhattan distance was, right? You take the absolute value of the difference in that. Euclidean is one that you will have been regularly using, where you take the square root on the difference of the value, square it, and then take a root. So that is Euclidean distance. So with Minkowski, depending on what value of p you take, that will end up being your effective metric. So I think I showed it in the code snippet area. So the effective metric, even though the chosen metric is Minkowski, the effective metric ends up becoming Euclidean because p equal to 2. Okay, so Minkowski is like a broader term in that sense. Is that okay? All right.
So Euclidean is subset of Minkowski.
Yeah, you can kind of say it like that here. So it is just that Minkowski is this one used, like Minkowski is the metric setting used, but it ends up becoming the same as Euclidean when p is equal to 2. Okay. So here, I don't know which ones else are given. So you have Manhattan, you have Euclidean. So these are the ones that are there under Minkowski. So these other ones will, like for example, cosine is something you might see when you see similarity between texts. Maybe it is there in our syllabus. That time we could come to it. So there are different distance metrics also. Okay. So yeah, for k neighbors classifier and radius neighbors classifier, I'd recommend primarily knowing that the setting will have Minkowski as default, and you can pass depending on the value of p that you give. If p was equal to 1, then it would have simply have been Manhattan. So maybe let's do that slight change here and let's see if we can do p equal to 1. This is we want only this one, right? Come with this. This will give it as frame. This should be fine. This should be fine. Let's go back to the. Okay, here we have given p is equal to 1. What has changed? The R2 score was 0.19, 0.19. Now there is an improvement in R2 score just by changing the distance metric. Let us see if it changed with scaling. Scaling, okay, it is 0.68 again. but it is giving effective metric as Euclidean. Okay, I have to run this. Okay, now it changed to Manhattan. So in case you didn't realize what happened, so I changed p equal to 1, so it should have been Manhattan. And then run before will run all the cells before this one. And now when we run this, it becomes, it changes to Manhattan. Is that okay? Yeah.
Yes, sir.
Yeah.
All right. So coming to week 8, we just we discussed softmax first, and then we saw k-nearest neighbors. There's the same demos with, okay, there's a demo with California housing here also, and with MNIST. So this is classification, this is regression. It will mostly include the things that we just discussed. So if you have not seen already, I recommend going through these code snippets as well. Do the activity questions. The activity questions has a few mistakes. I'll discuss those in the next session. And then we have large scale ML and SVM for the next session. So the SVM, there's also some text part, which I'll be covering then. Yeah. Okay, please go ahead.
Yes, I was saying, please look on into like week 6 and week 7 graded assignment too.
Yeah, sure. I'll look at it. I'll look at it at the earliest, and I'll respond there. If there's a mistake from our end, I'll inform the team.
Yes.
Sir, why reminder was not sent for graded assignment, sir, tomorrow? Yesterday, I guess.
The reminders, it is not in my hand, so I think it is collectively sent for all courses.
Yes, sir. Actually, it happens like both the weeks deadline were tomorrow, yesterday only, na? So it was very confusing.
Okay, yeah, yes, but yeah, that's the thing.
I missed both, sir.
Okay. Yeah, so but that is, of course, it is something that the team does for all the courses together. And with that, I think it has. It's been informed previously. I know that once of the students had